Hello everyone and welcome to our lecture on energy for aviation physics. I am Dr. Chen and today we are going to explore some of the fundamental concepts that govern motion and the ability to do work, which are absolutely critical in the world of aviation. When you look at an image like this, a rocket launching into space, what you are seeing is a tremendous conversion of energy. Chemical energy stored in the fuel is rapidly converted into kinetic energy, the energy of motion, and the potential energy as it gains altitude. This chapter is all about understanding these different forms of energy and how they relate to one another. Let's start with one of the most intuitive forms of energy, kinetic energy. Kinetic energy is simply the energy of motion. Any object that is moving has kinetic energy. We calculate it with the formula K representing kinetic energy equals 1/2 mv squared, where m is the mass of the particle and v is its speed. A few key points here. First, kinetic energy is a scalar quantity. This means it only has magnitude, not a direction. It doesn't matter if you are flying north or east. If your mass and speed are the same, your kinetic energy is the same. Second, because both mass and speed square are positive, kinetic energy can never be negative. Mass positive, speed square positive, is only can be zero when the object is perfectly not moving. And finally, the SI unit for kinetic energy is joule. This slide illustrates the first point beautifully. The two blocks have the same mass and the same speed. They are just moving in different directions, as you can see. They have exactly same kinetic energy because directions doesn't matter for kinetic energy. Now let's look at the relation with mass. Kinetic energy increases linearly with mass. In the middle example, in this example, we have two blocks with the same speed, but one has twice the mass. The result, the more massive block has exactly twice the kinetic energy, because the equation goes as 1/2 mv squared. V are the same, then the kinetic energy proportional to the mass directly. The relationship with speed is even more dramatic. Kinetic energy increases with the square of the speed. In this example, the two blocks have the same mass, but one is moving at twice the speed. This results in 4 times the kinetic energy because the v square term in the equation. This is incredibly important in aviation. Doubling your airspeed quadruples the kinetic energy you need to manage. We can also talk about the kinetic energy of an entire system of particles, like this setup with two blocks connecting by a pulley. To find the total kinetic energy of the system, you simply calculate the kinetic energy of each part and add them all together. It's a simple sum of all the individual kinetic energy. Alright, let's test this concept with a quick question. A fighter jet is moving at 300 meters per second, and a private jet is moving 500 meters per second. If both aircraft have the same kinetic energy, what is the ratio of the fighter jet's mass to the private jet's mass? So they have the same kinetic energy. The equation we should have, let's use in MF for the fighter jet, VF for the fighter jet. This is the kinetic energy of the fighter jet. Likewise, we use the subscript P for the private jet. So this equation is a translation of the word, the sentence, they have the same kinetic energy, right? Kinetic energy for fighter jet, kinetic energy for private jet. 1/2 and 1/2 will cancel. So we want to find the fighter jet mass, private jet mass ratio. We want to find this ratio and rearrange this equation. Should give us this. And speed of private jet is 500 meters per second. Speed for fighter jet is 300. And cancelling out all the zeros, we have 25/9. So the correct answer is C for this quiz.